Hello everybody, welcome back to another day of notes. Today we're going to be talking about multiplying polynomials, which I'll show you a way that you will be very familiar to you, and I'll show you a new way that might be a shortcut for you, which always saves time and effort, which we love. So, let's go ahead and get started. Multiplying polynomials. The first way is distributing, okay? Distributing is basically exactly what it sounds like. Okay, so here's a problem. We have to multiply these two polynomials, so we have a monomial times a trinomial. We're going to distribute out this. So basically we're going to take the monomial and multiply it by each term in the trinomial. So 3x to the third times negative 2x squared. This is where the exponent laws really come into play. We have to know what these laws are, okay? With the numbers, 3 times negative 2 gives us negative 6. X to the third times x to the second, we add our exponents, so it gives us x to the fifth. Okay? Then we do it for the next one. 3x cubed times x plus, or times 5x. 3 times 5 is 15. 3x cubed times x, we add the exponents, gives us 4 for the new exponent, so we get positive 15x to the fourth. Last one, multiply 3x cubed times negative 7. Well, it's just 3 times negative 7 gives us negative 21, and we keep the x cubed. Okay? So we just make sure, so that's it. We just put it all together as one polynomial then, or one trinomial now. And we make sure it's in the standard form, so this has a degree of 5, 4, 3. Put it all together, and that is our final answer. Okay? Now, this is just distributing a monomial times anything, okay? What if we had a problem like this? It's a binomial times another binomial. We're still doing this distribution. What we're doing, though, is we're distributing an entire binomial. So we're taking this whole first one and multiplying it by the x, and we're taking it and multiplying it by the negative 6. So we distribute that out, it looks like this. X times the x plus 3. Negative 6 times x plus 3. So from there, we go ahead and distribute again. So we're going to do x times x. That gives us x squared. And we got that by doing this part. Okay? Then we do x times 3. We get 3x. No, what did I do? Oh, dear. 3x. There we go. I don't know why I did it in a weird order. That's okay. Which we did this one. 3 times x. Negative 6 times x gives us negative 6x, which we got from doing these two. And negative 6 times 3 will give us negative 18, which we do here. So you can see that we actually multiplied each term by the other two in the other parentheses. So x got multiplied by the x and the negative 6. 3 got multiplied by the x and the negative 6 as well. Okay? So we go ahead and do that. Then we just combine like terms. Negative 6 and 3x are like terms. We combine them. We get x squared minus 3x minus 18. We make sure it's in standard form. This has a degree of 2, 1, and 0. So it is. And that's our final answer. Okay? Another way you can think of it is using a Punnett Square. So let's see. This is a Punnett Square. You guys saw it in science, or you're learning about it in science now. A lot of these Punnett Squares are used for genes, like figuring out how genes work. I don't know. I don't really pay attention that much to it. But it's great for math because it can do the same thing. Okay? So we do the same problem. We had x plus 3. We basically take each term. For the first binomial, I put it on the top. Second binomial, I put it on the bottom, or on the side rather. And then I fill in each square by doing multiplication of the parts that make up that square. So x times x, x squared. X times 3 gives me 3x. X times negative 6 gives me negative 6x. Negative 6 times 3 gives me negative 18. Those are the same terms we got by distributing. This is a little bit more, this is more visually organized. So those people who like a visual, they're going to like this a lot better. And you can use this Punnett Square for anything, even if it's a monomial times a trinomial. You just do a 1 by 3 box. Okay, so basically the size of the box is made up by how many terms you have in each polynomial. Okay, once I have this though, I'm going to add up all of these boxes. So Did I write it out? Yeah. So, oh, I did it that way. I just took them all and put them together, and then I combined like terms. So again, these were my like terms. Okay. And these colors reference back to what I was, like those arrows. That's just the distribution arrows. But the two like terms I combine, and then I just make sure it's in standard form. 2, 1, and 0 for the degrees. It is. That's my final answer. Okay. So Punnett squares are great for the visual reference and to make sure that you multiplied all that you had to multiply. Okay. Because I know sometimes with the arrows we forget about that last one, and that's the problem. This one, if you have an empty square, you're going to notice a little bit more. Okay? So, the next thing for multiplication is called FOIL. So, FOIL. Now, FOIL only works with binomials. Okay? It will only work if you're multiplying two binomials. So, here is the same example again, and I'll show you what I mean. Okay? Did I write it down? I didn't write it down anywhere. Alright, but on your notes it says it, okay? F stands for first, O stands for outer, I stands for inner, and L stands for last. So what we do is we get our binomial, and then we take it one thing at a time. So the first term of each binomial we multiply together. So x times x gives us x squared. O stands for outer, so we multiply the outer terms of this whole thing. So x and -6. It gives us -6x. I stands for inner, so the inner two terms we multiply together. 3 times x gives us 3x. And then L stands for last, so the last terms of each binomial. 3 times -6 gives us -18. Again, combine like terms, and you get the same answer. So 3 different ways that'll work for binomials. Really, there's only 2 ways that work for anything else, because FOIL will only work for binomials, okay? But you can kind of choose which method you want to use. FOIL is like the bam, 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 you kind of know. You know exactly what to do. Punnett Square is great for organization, distribution. To be very honest, my least favorite because it looks a little messy. But it's the most familiar to stuff that we've already done. So it's kind of your choice. Now that I've shown you the same example 3 different ways, you guys do the try on your own and figure out which ones you want to do. So both of these are 2 binomials. I would suggest trying 2 separate methods to see, so you can get practice with either one. Okay? So maybe one you try with FOIL, the other one you try a different way. I don't want you using both FOIL for this, even though you could, because I want you to get used to another method in case it's not 2 binomials. So you have something else in your back pocket if you need it. Okay? But that's your try on your own. And we will go over it next class, okay? So, if you have any questions, please feel free to write them down and we'll talk about them next time I see you, okay? Bye!